Okay, like I was saying, we talked about composition just now, and Allison demoed some code for us that demonstrated classes as we've been going over them. And today we'll be going over inheritance, another aspect of classes and instantiation that's pretty fundamental to being able to maximize how you utilize classes. And so we'll go through the slide deck. We'll go through a few VS Code examples. We'll break, and then you'll all work on both classy hotels and ice cream and freezers today. I think ice cream and freezers is a group or at least a paired challenge. I'll double check after this. Let's see. So, what is inheritance in OOP? So nobody has read ahead. Does anybody want to take a stab at trying to describe or define inheritance?
It's when you um, inherit a class within another class. And so um, all the methods of the class that you inherit will now be available to the child class. The README, I did read it with the video games, and something that it made a point to reference is that the child can have the access to the parent class, but the parent class will not directly have the access to the child class.
Yeah, all of that is absolutely correct. I want to add to that last point, though, that it is possible to give the parent class access to the child class. I know if I don't remember if I went through that at all last week. I know I was working on a demonstration of if I didn't, you know, if I could talk through that again later. But basically, parent class, there are ways to be able to. Oh, I do remember now, actually. Sorry, forgive me. I do remember. We were going through the um the classes, and I had created that extra set of I don't know, examples, and I threw it inside a gist. The last part was kind of confusing, so I reworked it during class, and then I sent a link. In that example, there are, let me actually just pull that up. Pretty sure it should be easy to find. Yes. Right. So from last week, is it still sharing the right thing? Should be sharing this entire. Okay, cool. From last week, we had this gist, and at the very end, we talk about class methods again, right? And let's scroll down until we get to class method decorators. Yes, it was the decorators that was kind of confusing. And again, that was on me, so my bad, and I appreciate the feedback. But in this revised edition of the class method decorator example, we have three various class methods that all kind of demonstrate different ways for a parent to interact with a child. So here we are tracking all instances. And with that, we are able to then call upon those instances later on and update an attribute that was passed down to them. So it's kind of like a programmatic approach. It does require a bit of coding beforehand. So like you say, Mike, like they naturally inherently they can't access the child, but there are ways to make that possible, right?
Yes, if you, I mean, one of the ways would be like this, which was something that I did for the apple tree. Anytime I made an apple, the object itself, it would get passed to the parent list,
Mhm.
right? So yes, there are ways too, but just directly it's not able to, right?
Right.
Okay.
Cool. Yeah, but very good call out. I just wanted to yeah, highlight that. That was a good point to bring up. So back to inheritance overall, we have this definition here that says it's a mechanism where properties are passed down from a parent class to a child class, just like Mike said. Another way of saying it is the derived class, which is the child, inherits properties from the base class, which is the parent. And again, a lot of these terms are somewhat interchangeable. It's not completely black and white. So why do we want inheritance? One reason would be to create relationships between classes. Another would be to be able to reuse code and to make changes to objects more consistent and more seamless. Not really sure what I meant by that bullet. This is an old slide deck, but let's look at this code and can someone tell me what it's not necessarily what's wrong with it, but what can be improved in this code?
Well, you got duplicate variables, right?
Mhm.
So, the duplicates are not, one of them does not need the same variable, right? So it needs to be unique. Um, and and so we got programmer and accountant. And so yeah, doesn't need both. You just need one method to store the main names, right? You can classify their department with the string, maybe. I mean, so
And let's say what I don't know, coding principle does that reference?
dry.
Exactly. Right. Don't repeat yourself. And so we could utilize inheritance to make the code more dry. And here we have both a programmer and an accountant who are then um, subclasses of a basic employee. They are able to then inherit the properties that are shared between them while also adding new properties that are unique to each subclass. So programmers, let's say, will want to track the languages that they know, and then maybe our accountants will we want to track their certifications, and we definitely want to be able to track their name and employee ID and department, regardless of which role they are. So that's a use case for inheritance. And we already know the syntax for doing that. Let's talk about different inheritance models. So what we've been looking at so far is a very simple parent to child relationship. It's single inheritance. This last example is an example of, well, yeah, I would say that's still a single inheritance. But then there's more complex cases where a child can inherit from multiple parents, or we have an additional tier of inheritance, a parent to a child to a grandchild. And any combination of these can be thought of as a system that demonstrates hierarchical inheritance. So just the more complex it is, the more it utilizes various uh, ways of inheriting that's that creates a hierarchy. Did did you use super at all yesterday? The super built-in super method?
Yeah, we used it.
Okay, cool. So it's a really handy dandy little method to instantiate the parameters that were inherited from the parent class. So that's essentially that same slide. And then I'm pretty sure Omer went over the composite reuse principle because he talked about composition yesterday, that principles that classes should be favoring polymorphic behavior and code reuse by composition rather than inheritance.
Polymorphic.
Yeah, I think about polymorphic as maybe being not the best word, but when we talk about, like, let's say the mutability of subclasses or objects or variables in general, um, it just makes more sense to use composition over inheritance. And that's not a really great example. That doesn't really describe it. Yeah, let's not worry about this slide. I think it could use a lot of rewording and reworking.
The way I noticed the difference when they were trying to say inheritance versus composition with Omar, I don't know if this is true or not, but when you're inheriting, you're passing another class as a parameter in a class you're trying to create, right? So it's taking all those uh, methods and if you're putting the variables in the super section, right? Whereas if you're trying to do a composition, you're instantiating a class and passing in another instantiated class within that new instantiated class.
Yes. Yes. Yeah. And the simplest way to kind of differentiate the two is the whole has is versus is argument. And yeah, I'll see if I could go back to that slide and make that better. But that's essentially it for the slide deck. Let's go to today's README. And there is an example where we have multiple systems. We have an offensive system and a defensive system. And the systems are utilized by the knight class. And so that's an example of composition. Now, let's say we know that there are, in a game like this, there's more than one way to attack an enemy. And really one key ingredient to making engaging games is to have dynamicism, right? So can you vary up the ways that the player interacts with elements in that world? One way to do that right now would be to have different kinds of offensive systems. So we have, for example, a melee offense versus a ranged offense. Now we're giving players the element of choice and adding a bit of depth to their experience. But at the end of the day, they're both still offensive kind of functions. And so it makes sense for them to inherit the core properties that they share from a parent class, the offensive system. Now, I did try running this code. I don't really like the way the print statements rolled out. Has anybody else tried running this on their local machine? Oh, I'm lost. I can't even find it. There we go. If we expand this up and our script, it just immediately runs all of these functions. So maybe what we could do instead is play around with this entire thing. So let's do a from main.py import. Ooh, but then I'm going to have to import all of these. Yeah, let's not do it that way then. Let's just talk through. I don't want to do that anymore. Let's talk through what's happening here. We instantiate a night class. The night class then calls its attack method, which utilizes the melee offense and passes in a parameter or a value to a parameter sword. And it also has a defense system that it calls in these next two lines of code. I mean, this is a pretty straightforward example. Everybody gets like where composition and inheritance is used in this example, right?
Where does a static method come from?
Where does a static method come from? Okay, so we have another decorator here, a static method. Let's see. A static method does not receive an implicit first argument. To declare a static method, we use this idiom. It can be called either on the classes or an instance. Both the class and the instance are ignored, and neither is passed implicitly as the first argument to this method. So it's similar to those found in Java or C. Okay, that implicit first argument that it's talking about, I believe that's in reference to self. So I'm a little rusty on this. It's been a while since I've written in C sharp, but in Unity, when you're, let's say, trying to instantiate a repeatable class, right? Like a projectile, for example. If it's something like that simple, it may not need a self with the binding of all these other parameters. And so by making it a static method, you're essentially simplifying its behavior. What else? Both the class and the instance are ignored, and neither is passed implicitly as the first argument to the method. Yeah, that's sorry, that's not a great explanation. Let's see if there's a good explanation in. Nope. Yeah, it's just another decorator, and the way that I'm reading this right now, I'm thinking just because of the simplicity of what's happening here, they're defining it as a static method. I don't really know. This is a new example. Like I don't recognize this from the previous curriculum. So I don't really know if there's any more to it than that. Great question. It's got me stumped. I'll do a bit more digging and I'll get back to you. Any other questions on this? Okay, cool. Let's see. How are you feeling about inheritance so far? Okay, we got some confetti. Okay. I think we are in a good place then. I think if there's nobody that's confused by any of this, it's yeah, I don't want to say it's like simple or anything. Yeah. Let's open up breakout rooms. We will take a break and oh, I'm sorry. I did have not been reading the chat.
Well, what I'm seeing, like from what I'm reading on static methods, is that you can utilize it without having to instantiate the class, if I'm understanding that right.
Okay.
It's like a standalone function within the class itself that has no bearing on the instantiated class. Like you can utilize it and it doesn't change anything within the class. It's itself. It's static. It's itself.
Okay. And in the case of the behaviors here, we have a block and a dodge, and all they do is print a statement. Is that why do you think it was utilized here? I'm not even sharing anymore, sorry. Inside of the README though, where you see uh, the static method decorators for the defensive system, Sean, why do you think that's being used there?
Uh, let's see here. So in the engage defense, which is towards the bottom of all the code here,
Mhm.
it's gonna look at its choices, which I don't know what choices exactly does. I'm just assuming that it has choices true or false, and based on these weights, I guess this is something else I'd have to look into. It chooses true or false. So if it gets one of those, if do block meaning true, then it's going to do the block function, which will always just print out block. It doesn't change anything.
Mhm.
And else it's going to do dodge. So if you're doing the engage defense method,
Mhm.
I'm assuming it's just going to run this static method and print out block. It's not going to change anything within the class itself. So that's kind of talking out my rear here, but that's kind of what's making sense to me.
Would there be any difference if we remove the decorator at all?
I don't think so, not in this, not with how it's being used. But if you wanted to, I guess, call out dodge or block without instantiating a class, from what I'm seeing, maybe you could do defensive system dot block and it would still have the same result without actually creating the class,
Mhm.
instantiating it to a variable.
Yeah, it sounds about right. Tisdale, does that kind of help give any more insight into the decorator?
Yeah, a little bit. I think I have to play with it on my own to really understand it.
Mhm. Yeah. I think that
I was just asking because I saw on there earlier, right before class started, and I didn't know if it was something that we were going to be going over or learning, or if it's just something that happened to be used in this code.
yeah, it just happened to be used in this code, and kind of like as we looked at it, it's not like really critical to what's going on. I think it's here as an example. Like Sean pointed out, if we were to call the instantiated defensive system and use dot notation to call either block or dodge, it would essentially have the same effect. But yes, I think it's a great idea that if you want to play around with it, that might give you more insight into like ways to utilize it or really, yeah, if you could find a use case in whatever code you're working on and it has some kind of a, well, maybe not necessarily like a profound impact, but some kind of like evident change, that would be great to share with the class during stand down.
It does look like the only difference, I guess, between like those versus the other one is that doesn't have self,
Hmm.
like the block and dodge, so that,
Right, because
because of
it,
this,
oh, go on.
I would say, yeah, I saw, like, would the static method then be like, since it has that, you don't have to have the self.
Yeah, because we use the decorator, we don't need to pass in the self. Yeah. I mean, that's a good call out because that might be, well, from a teaching perspective, I could see why whoever wrote this did that. It's just a nice way to demonstrate another way of writing a method in a subclass. But yeah, I am sorry, I haven't used it myself in any way that gives me like any deeper insight on that. Okay, I think that's about it. I did have one more example I was playing around with. It's not 100% complete. It's a React 3 fiber project. We use composition to generate different um, classes, and then there's a bit of inheritance for this light component. But if you all already have a pretty good grasp on composition and inheritance, going through it right now would be like beating a dead horse. So I will open up breakout rooms and you all can work on your challenges. Sound good? Cool.